Okay, in this video, we're going to go over how to use the primary trigonometric ratios to solve for angles and sides in triangles. So we learned in class, we can always label the sides of a right triangle from the perspective of what we call a reference angle. We'll go over some of these terms quickly, and then we're going to do a few problems in this video. So the way we label these, for example, here's a right triangle. The reference angle is kind of my perspective. Where am I standing? We often call that theta. It's a capital Greek letter, theta. The side across from the reference angle. So if I look directly across from theta to the side, we call that side the opposite. The side across from the right angle, which is always the longest side, is what we call the hypotenuse. So hopefully you learned that term in grade 8 or grade 9 when you were talking about the Pythagorean theorem. And then this third side is called the adjacent side. So adjacent in English means next to or beside. So it's next to the reference angle, or it's next to or in between the reference angle and the right angle. So that's where we're always going to label those three sides. And then all the trigonometric ratios are numbers or ratios stored in your calculator. And we can use this mnemonic. Again, we talked about in class, a mnemonic is a memory tool or memory device. So we use SOHCAHTOA to remember the ratio. So sine is opposite divided by hypotenuse. That's the SO part of SOHCAHTOA. Cosine is adjacent divided by hypotenuse. And tangent is the opposite divided by the adjacent. Okay, so we're going to use these three ratios to solve a bunch of problems with triangles. In our first step, always, it's going to be to label the three sides from the perspective of the reference angle. So in this example, I want to find this missing side length x. I'm given this angle of 65. Let's label all three sides from the perspective of 65. So there's opposite. Hypotenuse is my longest side across from the right angle. And then 11 centimeters is my adjacent side. So if I'm trying to find x, I want to pick one of these trigonometric ratios to use. And you notice here that I want to know x and I know 11. So I want to know the opposite side and I know the adjacent. I don't know the hypotenuse. I don't want to know it. So I'm concerned about opposite and adjacent. Well, which ratio uses opposite and adjacent? Well, it's tangent. So we're going to use the tangent ratio. So I'm going to say the tangent of angle theta is op over adjacent. We always kind of start with that target. And then I'm going to plug in what I know. Well, I know our reference angle. In this case, I know angle theta is 65 degrees. The opposite side I don't know. We've called that x. That's what we don't know, what we want to know. And then the adjacent side here is 11. So when we set up the ratios, there's always going to be two of the three that we know and one of the three that we're trying to solve. We can solve this ratio using cross multiplication. To see that, it might help to write tan 65 over 1. Tangent of 65 is just a number that your calculator is storing for us. So again, anytime we're solving by cross multiplication, I'm going to multiply the diagonal that doesn't include the x. So in this case, that's going to be 11 multiplied by tan 65 and divide by what's left over. In this case, I'm dividing by 1. I don't really need to write that down. So what is 11 times tan of 65? Make sure always that your calculator is set in degree mode. It should say D or DEG. If you have a scientific calculator similar to an Android phone or where you can see what you're typing, you can just type directly in 11 tan of 65. And we normally, in this course, are going to round side lengths to the nearest tenth. So x would be 23.6, and our units are centimeters. If you have a calculator, looks more like this neon green one I've got on the video here. Again, I want to make sure it's in degree mode. This is more like your iPhone. So if someone's using an iPhone, I really don't recommend it. They're not as good. I've got to do 11 times 65 tan and then press equals. So I do get to the same place. A little bit more annoying. I've got to type things in a different order when I can't see what I'm writing. So the advantage of these scientific calculators, Google works like this, the Android phone works like this, is that I can directly type in exactly what I've written down. Let's just do one more example for finding a side length. Again, here's my reference angle, 52 degrees. So I'm going to start by labeling opposite. Hypotenuse is my longest side, and then adjacent is the third side. Okay, so I want to know the hypotenuse, and I already know the opposite. So op and hypotenuse. Well, which side uses opposite and hypotenuse? Which ratio uses opposite and hypotenuse? Well, it's my sine ratio. So again, let's start by writing down our target. Sine theta equals opposite divided by hypotenuse. And then I can start filling in what I know. Again, I know the reference angle. I look from the perspective of 52 degrees. In this case, I do know the opposite side. It was 4.2. I don't know the hypotenuse. That's what I want to know. That's what we're calling x. So again, there's always one of these three that I'm going to solve for. Our unknown variable could be in any of the three positions. So be really careful, kind of slow down as you're picking which ratio to use, and then as you're filling in the data from the problem. Again, we can solve by cross multiplication. So I multiply, so if I want to solve for x, I'm going to multiply the diagonal that doesn't include the x. So 4.2 times 1 is just 4.2. And then divide by what's left over. That's this number up here, sine 52, which again is just a ratio stored in our calculator. Again, I'll show you on both calculators. So we have 4.2 divided by sine 52. So I've got x equals 5.3. It's a side length. What are our units here? They're meters. Again, if you're using something that's more similar to an iPhone or maybe kind of your cheaper dollar store calculator, that's where I got this one. Pretty good deal. It works just fine. I'm going to do 4.2 divided by, 4.2 divided by 52. Then I've got to press sine, and then I'll press equals. And I do get the same answer, which I'm rounding to 1/10. And you can try this third question on your own. Again, I would follow these same steps. Label the three sides, opposite, adjacent, hypotenuse. Pick which trig ratio is appropriate. Write down your target, plug in the data from the question, and then solve by cross multiplying. That's so we can use trig ratios to solve for missing side lengths. We can also use trig ratios to find for missing angles. We'll do a couple examples like that as well. Here, I do know two of the sides. I want to find this third side, theta. Again, I'm going to label all three sides from the perspective of theta. So opposite is when I look across from my reference angle. Hypotenuse is my longest side. And then I usually like to just put adjacent as the third side. Okay. Again, we want to pick our ratio. You might want to write something like SOHCAHTOA up at the top of your page. Which ratio uses opposite and hypotenuse? Well, it's sine. So I'm going to use sine. I don't know the adjacent side. I don't need to know it, so we won't include it. So sine of theta equals opposite over hypotenuse. Okay, I don't know theta. That's what I want to find out in this question. But this time I do know both sides. So it's 19 divided by 34. Okay, how do I find theta? How do I get theta by itself? Well, I want to move this sine to the other side of the equation. To move from the other side, I need to do the opposite, right? I need to do the inverse operation. The opposite of adding would be subtracting. The opposite of multiplying is dividing. The opposite of square is square root. The opposite of sine is sine inverse. So it looks like sine to the power of -1. So I'm going to take the inverse sine of 19 over 34. So what I'm doing is I'm looking up this ratio in my calculator, and it's going to tell me the associated angle. Again, if you have a calculator that looks like this, a scientific calculator, I'm going to start by pushing second. On some of your calculators, it might say shift, and then I press the sine button, and that will create this sine -1. So the second key starts using the button has a second function, which is often written above the button. Then I can do 19 divided by 34. Remember to close your bracket. So again, the advantage of these calculators is I can write in exactly what I've written on my page. And that's going to be 33.9. Well, what are my units? Well, that's degrees. We're going to round to the nearest degree. So that angle must be 34 degrees. So any right triangle, if I'm looking from the perspective of a 34-degree angle, the ratio of opposite to hypotenuse is going to be 19 over 34. So I can look up going both directions in my calculator. Again, if you don't have a calculator like mine, maybe if you're using your iPhone, I would do 19 divided by 34 first, press equals. So you're generating the ratio yourself. Then again, I'm using the second key. I think it does say second on the iPhone as well. And then you pressing sine. So then I'm using the sine -1, and I get the same thing, 34-degree angle. Again, I'll do one more. So if I'm finding an angle, the only real difference is instead of cross-multiplying, I'm using that inverse function. I'm still starting the same way. Opposites across from the reference angle. Hypotenuse is my longest side. Adjacent is the third side. Then I'm picking my ratio. I have information about opposite and adjacent, so I'm going to use tangent, because tangent is the only ratio that involves opposite and adjacent. What do I know? Well, I don't know theta, that's what I want to find, but I do know opposite is 4.2, divided by adjacent is 8.5. To get theta by itself, I move the tangent to the other side by doing the inverse of the tangent function. So I'm taking inverse tan of this ratio. And again, I'll just show it on one calculator in this example. And then I'm going to round degrees to the nearest degree. So if I'm finding an angle, 26.2 rounds down to 26, and then I'm including my units again. The units for angles in this course will always be degrees. Here's a third one that you're welcome to try on your own. Again, please make sure that you're trying this with your calculator to make sure you're getting the same numbers. If you're having any trouble with that side of it, please let me know. Send me an email. And once again, thanks for watching the video.